Let's take a moment to remember the excitement back in February of last year, when NASA successfully landed its Perseverance rover on Mars. Many may recall the anticipation as the spacecraft touched down safely on the red planet, opening a new chapter in space exploration. The crater you see in many of the images was actually a lake about 3.2 billion years ago. This means the rover is examining an ancient environment, providing a glimpse into Mars as it was billions of years ago. Perseverance has sent back some of the most remarkable footage ever captured on another planet, thanks to its advanced cameras and state-of-the-art technology. It has delivered high-definition 4K images that make you feel like you're right there on the Martian surface. As Perseverance explores the planet's ancient terrain, it uncovers important new clues about Mars' history and its potential to have supported life long ago. This mission builds on the achievements of its predecessor, the Curiosity rover, which was the first to send us 4K visuals and helped push the boundaries of what we know about Mars and space exploration in general. You might wonder why NASA invests billions of dollars just to send back pictures and data from Mars. But these are much more than just photographs. To truly appreciate why these missions are so important, it helps to understand the whole story, starting with earlier rovers. Over the past 2 decades, rovers have played a vital role in expanding our knowledge of the red planet. NASA has launched several groundbreaking rovers, each one more sophisticated than the last, designed to tackle different scientific goals. The first major ones, Spirit and Opportunity, were launched in 2003 and began searching for evidence that water once existed on Mars. Their findings helped confirm that Mars once had the right conditions to support life. Then, in 2012, the Curiosity rover landed in Gale Crater, revolutionizing our understanding of the planet, with detailed images and valuable scientific data about its climate, geology, and habitability. Perseverance arrived in 2021, equipped with cutting-edge instruments to search for biosignatures, signs of past life, and to collect samples that future missions hope to return to Earth for deeper study. These rovers have opened a window for humanity to see Mars in ways never before possible. They've sent back breathtaking images and data that help scientists visualize the planet's landscapes and geological history. Curiosity's journey, for example, began with its launch from Cape Canaveral in November 2011. It traveled more than 350 million miles through space before landing safely in August 2012. It touched down in Gale Crater, a flat area near Mount Sharp, a giant mountain rising about 5.5 kilometers or 3.4 miles high. Gale Crater was chosen because it offered a diverse set of geological features and strong evidence that water once flowed there. Curiosity's mission was to study Mars' climate, geology, and to investigate whether the planet could have supported microbial life in the distant past. To do this, Curiosity examined the Martian soil and atmosphere, searching for key elements essential for life as we know it: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. It also looked for features that might indicate biological activity, like biosignatures or organic molecules. One of Curiosity's most important scientific tools was its laser, which it used to vaporize tiny bits of rock. The vaporized material created a plasma that the rover's instruments could analyze to determine the rock's chemical makeup. This helped scientists map out Mars's history of water presence and volcanic activity. Additionally, Curiosity studied the Martian atmosphere, focusing on the cycling of water and carbon dioxide, crucial for understanding how the planet's climate evolved over billions of years. These observations are vital to explain how Mars transformed from a warmer, wetter world into the dry, cold desert we see today. Curiosity also measured radiation levels on the surface to assess the risks future astronauts might face. Understanding. Radiation exposure is essential for planning human missions to Mars. In 2013, Curiosity made a groundbreaking discovery when it found evidence of an ancient stream bed indicating liquid water once flowed through Gale Crater. The rover also detected clay minerals, which only form in the presence of water, reinforcing the idea that Mars had an environment potentially capable of supporting life. One of the more intriguing aspects of Curiosity's mission has been its Measurements of methane levels in the Martian atmosphere. Methane on Earth is often produced by biological processes, so detecting it on Mars has sparked questions about whether microbial life might exist beneath the surface, or if the methane comes from geological activity. Apart from the scientific discoveries, Curiosity has transformed how we see Mars visually. Its cameras have sent back some of the most iconic images of the Red Planet, capturing stunning views of rocky terrain, weathered landscapes, mountains, and valleys. These images have given people around the world a better sense of what it would feel like to stand on Mars. Then came Perseverance, which is shaping the future of Mars exploration and space science. In March 2021, Perseverance made its first drive on Mars, leaving the very first wheel tracks on the planet's surface, a small but historic step. Besides exploring the terrain, the rover is also collecting rock, soil, and atmospheric samples to be brought back to Earth by future missions, marking the first time Mars samples will return home for detailed analysis. Perseverance has already made some exciting discoveries, like unusual leopard spots on a rock that could provide clues about Mars' potential for life billions of years ago. The mission has captured the imaginations of millions worldwide. NASA's Send Your Name to Mars campaign invited people to submit their names, and over 10 million were etched onto microchips attached to the rover. This symbolized the shared human interest in space exploration. The mission also paid tribute to healthcare workers during the COVID-19 pandemic, with a special commemorative plate on the rover. Additionally, the parachute that helped slow the rover's descent carried a secret message: "Dare mighty things," a motto that has come to represent NASA's bold and ambitious goals. We've also received fresh and captivating images from Perseverance's landing and early exploration. Photos show the smoke plume from the descent stage and views from hazard avoidance cameras that help the rover navigate safely. Panoramic shots reveal the vast, rugged Martian landscape stretching out as far as the eye can see. Other images include aerial views from the Mars Reconnaissance Orbiter, which captured Perseverance from above. The rover has also taken reciprocal photos with Ingenuity, a small helicopter drone that arrived with Perseverance. Ingenuity made history by completing the first controlled flight on another planet in April 2021, a milestone that echoes the Wright brothers' first flight on Earth over a century ago. Ingenuity has since provided video and audio from its flights, including footage from its fourth flight in late April 2021. It even gave us a unique aerial perspective of Perseverance during its 11th flight in August 2021. All these images, videos, and data continue to deepen our understanding of Mars. They mark important milestones in human space exploration and serve as inspiration for future generations of scientists, engineers, and space enthusiasts. The discoveries made by these rovers not only teach us about Mars's past, but also help prepare humanity for one day sending people to live and work on another planet. It's a testament to human curiosity, ingenuity, and the desire to explore beyond our own world.